This is the first chapter of class 8 mathematics chapter, that is the first chapter of class 8. This is rational number. The chapter's name is rational number. Okay, before starting what is the rational number and what is the definition of the rational number, we have to the knowledge of some other numbers, that is your natural number, then whole number, then integers, and then at the last rational number. So here I have written the definitions of the what is the natural number. So here natural number and numbers including all the number, that is 1 2 3 4 except only 0, that is 0 is not included in the natural number. So here the natural number is 1 2 3 4 and goes on up to infinite. Then what is the whole number? All the natural number including 0 is known as your whole number. Then integer, all the whole number with their positive and negative sign, it is known as your integers, and collection of these all, it is your rational number. So what will be the definition of the rational number? The rational number definition is here: rational number, a number that can be in the form of p upon q, where p and q are integers and q cannot be 0. So rational number can be p upon q, where q does not equal to 0. So earlier we have studied that what is the rational number. Okay, rational number is a number that can be in the form of p upon q, where p and q are integers and q cannot be 0. So rational number can be in the form of p upon q and q does not equal to 0. Where p upon q, that is on the numerator is p and on the denominator is q, both are integers. That means it can be positive or negative. So here we have written some examples. So first is 1, 2, 5, 7, 9. So these are rational or not? So firstly it is only 1 on the numerator, nothing on the denominator. So we have written here 1. Same as 2, we have written here 1. 5, 7, 9, same as on the denominator I have written 1. So on the numerator is also integer, on the denominator is also an integer. So 1 upon 1, it can be 1 upon 1, so it is 1. So all the numbers, that is 1, 2, 5, 7, 9, etc., it is your all rational number. Then the second one is your minus 4 upon 7, 2 upon 9. These are also rational number. Why these are the rational? It is minus 4. So it is a integers. It is a negative integer. On the denominator it is 7. Same as 2 upon 9. On the numerator it is 2. On the denominator it is 9. So also 2 upon 9 is also rational. Same as 11 upon 7 minus 9 upon minus 11. That is, it is also a rational. 4 upon minus 7. It is also a rational number. Okay. Now let's take one more example here. That is 0. But that is 0 is a rational or not? 0 is also a rational number, because 0 we can put on the denominator is 1. So it will be in the form of 0 upon 1. So 0 upon 1, it is also rational number. On the numerator it is 0. 0 is a integer. Okay, when we study in the integers, that is 0, 1, 2, 3, all the positive integers and negative integers including 0 is a integer. So 0 upon 1 is also a rational number. So for this homework, write some homework. There is some numbers I have written here. So you have to tell that which numbers are rational or which are not. So that is 7 upon 9, 3 upon 5, 6 upon 9, 3 upon 7, minus 9 upon minus 5, minus 3 upon 2, 0 upon 9, 3 upon 0 and 7 upon 6. In this, we will study about the properties of rational number. So first property we are studying here, it is your closure property. What is the closure property? Firstly, it is a property that tells us that if we add or take any operand, that is your additive, subtraction, multiplication, division, any operand you use here, the resultant number whatever you get, it should be belongs from the earlier set. Suppose when we add two natural number, the resultant number is n, suppose. So it should be again the natural number. It should be again the natural number. Then we can say that natural numbers are closer under the property addition. Same as when we add two whole number, again if we will get whole number, that means the resultant whatever will come, that will be your whole number. So we can see that this is whole number are closed under the operation of addition. Same as for the rational number. So when we add two rational number, it should be again the resultant should be rational number. So we can see that then when we resultant rational numbers are close under the operation addition. Suppose we have take here first rational number is 2 upon 3, second one is 1 upon 3. When we take LCM, it is 3 because the denominator are same. So we get here 3 upon 3 is 1. That means 1 is again a rational number. So we can see that rational plus rational, we get the rational number. We can see that rational number are close under the operation addition. Now second one is here for the subtraction. When you do the calculation for the subtraction, we have choose here the two numbers 7 upon 5 and minus 2 upon 5. We get here 1. Okay, 5 upon 5 is 1. 1 is again a rational number. So we can say that rational numbers are close under the operation subtraction. For the multiplication, again we get rational. Suppose you can take an example. Here we have choose some randomly, we have taken some number. You can take any rational number. So we have taken here 4 upon 5 and 3 upon 7. So we get again 12 upon 35 and is also a rational number. So we get again rational number multiply rational is again rational. But for the subdivision, when we divide rational by rational, okay, it should be rational. If it close under the operation division, so it should be rational. So suppose we have choose here 4 upon 5 divided 3 upon 7. We get here 28 upon 15. Okay, because 4 upon 5 division become multiplication, 3 upon 7 become reciprocal, so 7 upon 3, and when we calculate this we get 28 upon 15. This is a rational. We can see that this is a rational. But when we divide 4 upon 5, that means it is a rational. And 0, I have told you that 0 is also a rational number. When we divide 4 upon 5 a rational number by rational number, we get the value not defined. When we divide any number with the help of 0, the value is not defined. That means we can see that all the rational number are close under the division except 0. When we divide the 0 with the help of 0, we get the value not defined. That means it is not rational number. So we can say that rational number are close under the operation addition, subtraction and multiplication. Okay. First property we have studied, that is your closure property. Now this is the second properties of the rational number, that is your commutativity. What is the meaning of the commutative? Okay. When we add numbers in any order, the resultant number never change. That means its whole commutative property means we can see that the order of numbers can be changed without changing the result. That means here we have take two numbers, that is A and B. Suppose these are your rational number. When we add these rational number A plus B, or we have changed the order, here A plus B and here B plus A. If the both resultant have same answers, that means we can say that it is its whole commutative property. For the rational number, for the addition, if first suppose we have take one rational number R1 and another rational number R2. Okay, the order is R1 and R2 we are adding here. On the right hand side we are adding as R2 plus R1. Okay, we have changed the order here. Suppose you have choose any rational number. First rational number is 4 upon 5, second rational number is 3 upon 2. We have add here, taken an LCM and then calculated, it get 23 upon 10. When we add here 3 upon 2 LCM 10 and we do the calculation portion here, we get here 23 upon 10. In both cases, left hand side or right hand side, we get the same value as we have changed the order here, but we get the same answer. That means we can see that addition is commutative for rational number. For the subtraction is we have to R1 minus R2. When we change the order, we will get R2 minus R1. That means here rational number 1, rational number 2. and here rational number 2 minus rational number 1. Suppose we have choose here R1 is your 2 upon 3 and R2 is your 5 upon 4, and R2 same as when we solve this we get here 8 minus 15 after taking the LCM, and it is because greater sign in front of the greater is negative sign, so it is here minus 7 upon 12. Same as when we calculate it here, we get here 7 upon 12 is minus 7 upon 12 is equal to 7 upon 12. No, minus 7 upon 12 is not equal to 7 upon 12. So we can say that subtraction is not commutative for rational number. Now for the multiplication and the division. For the multiplication here, we have choose two rational number, R1 first rational number, R2 is second. When we multiply this in order, R1 multiply R2, and the another when we change the order as R2 multiply R1. So we have taken here two digits, that is your two numbers, that is your minus 4 upon 3 first rational number and second rational number is your 6 upon 5. When we calculate these, we get here minus 8 upon 5 and same as here minus 8 upon 5. Same answer. That means we can say that multiplication is commutative for rational number. Now comes for the division. When we divide one rational number with the help of second rational number, or now we are changing the order, R2 divided by R1. Suppose R1, that means your first rational number we have take here 14. Second rational number we have choose here 2. When we divide 14 divided by 2, we get here 7. And when we change the order, we have suppose that R2, that means the rational number 2 is 2 and rational number 1 is 14. When we divide 2 with the help of 14, we get here 1 upon 7, not 7. So you can see that 7 is not equal to 1 upon 7. That means division is not commutative for the rational number. That means only two property, that means your addition and your multiplication holds the commutative law. For the rational number is your associativity. Okay. In the associativity, grouping of numbers can be changed without changing the result. That means here we are changing the group. Firstly, we have take here A plus B plus C. That means suppose we have taken any three numbers. These are A, B, C. So firstly, we have make the group that is your A and B, that is A plus B, and then we are adding this with C. And here on the right hand side, last two numbers we have made the group because we have changed the group that, and then we will add it with the A. Same as for the rational number. So we have taken here, suppose R1 is your first rational number, R2 is your second and R3 is your third rational number. So here when we made this group, that is R1 and R2 group, and then we will add with the R3. Okay. Suppose we have choose here R1, that means your first rational number is 4 upon 5, second rational number is 2 upon 7. When we calculate this, and the calculation portion is this, and plus 3 upon 5, that means, and then we add this to 3 upon 5. We get here 59 upon 35. LCM of 5 and 7, it is your 35. And then calculation is here 35 and 5 LCM is 35. Again it's get 38 plus here it is 21 and you get here 59 upon 35. Same as when we calculate the right hand side, that means here R1 plus R2 upon R3, because firstly we have to solve this portion. Okay, grouping portion we have to solve. So we have solved this one, that is your 7 and 5 LCM 35 and become 31 upon 35. When then calculation here you are seeing that 59 upon 35 on the left hand side, and here on the right hand side it is 59 upon 35. Both have the same answer. That means we can say that addition is associative for rational number. Same as for the multiplication, you will take any three rational numbers. Suppose we have take here R1, R2 and R3, and then you will make the group. First two group you will solve, that is your first group is R1 multiply R2. Same number as we have choose here 4 upon 5 multiply 2 upon 7. It gets your 4 to the 8 and on the denominator 5 7 the 35, and here multiply 3 upon 5 equal to 4 upon 5, as we have taken here another group, that is R2 and R3 groups. Here we have choose which group, R1 and R2's group, and here we have taken second rational numbers group and third rational number group. Then we get here 2 upon 7 multiply 3 upon 5. It is on numerator it is 3 to the 6 and 7 multiply it is 35. Okay, so on left hand side you are getting here 24 upon 175 and here 24 upon 175. Both have the same answer. That means we can see that multiplication is associative for rational number. You will do one thing for the subtraction and the division, you will do it yourself. Okay, and you will get that both subtraction and the division not holds the property of commutative. Now here we can say at the last that the operation addition and multiplication are commutative for rational number, associative for rational number. Okay, for which operation we have choose addition and multiplication. Now comes to your next topic, that is your identity. What is the identity? It's yourself. Okay, staying the same. We can see that staying the same is your identity. That means when we add any number, tell me any number when we add with the 9. Again we have to get 9. So you will say 0. We can say that additive identity is always 0 when we add 0 with the help with any number. Any number you take 10, 20, 30, 7, 9 and add it with 0, you will always get again 9. And for the multiplication it is 1. And in the inverse, additive inverse is always minus a and multiplication is always 1 upon a. Okay, because 9 with added 2 minus 9, it's get 0. Okay, and in the multiplication when 9 is, and it will be your 1 upon 9, it's your. Okay, so these are your inverse and this is your identity. Now today's our topic is representation of rational number on the number line. So here today's topic is representation of rational number on the number line. In earlier classes you know that how to represent the whole number, natural number, integers on any number on the number line. So here in this class the topic is representation of rational number. So here we have take a question. With the help of this question we will learn how to represent the rational number. So here the rational number is 1 upon 5. We have to represent this on the number line. This is your 1 upon 5. This is a rational number. We have to represent this on the number line. So we are doing this question within a step. This will make the question easy. So first step we have take draw a number line. So we have draw a number line here and we have represent here as a 0. Because it is 1 upon 5, it is a positive number, so we will represent it on the right hand side of the 0. So here now the second step is divide the number line into 5 equal parts. Why the 5 equal parts? Why we are not dividing it into 10, 8, any other numbers part? Because on the number line, on the rational number 1 upon 5, on the denominator is 5. On the denominator is 5. The denominator tells us that how many parts we have to make. Here we have to make how many parts? It is your 5. So we will make here 5 equal parts. So here it is 1, 2, 3, 4, 5. We have make here 5 equal parts. Now the third step will be name the first division as 1 upon 5. So here we will write here 1 upon 5. We will write here 1 upon 5. Here 2 upon 5. Here 3 upon 5. Here 4 upon 5. Then 5 upon 5 and 6 upon 5 and so on we can write here. Okay, so here 5 upon 5 means 5 upon 5 become 1. That means it comes between 0 and 1. So between 0 and 1, how many parts we have make? 5 parts. 1, 2, 3, 4, 5. So on the denominator each and every rational number we will put 5 because on the main rational number on the denominator it is 5 and we are dividing here into 5 equal parts. We have make here 5 parts just like 1, 2, 3, 4, 5. That's why we are on the denominator we are writing here 5. So that means it is 1 upon 5. The question was we have to represent 1 upon 5. So it will be represent where? So this is your representation of the 1 upon 5. So here we have take one more number just like 7 upon 9. here we have changed the number. Examples, 7 upon 9. On the denominator it is 9. So how many parts we will make? 9 equal parts. So we have drawn a number line. We have divided into 9 parts, just like 1, 2, 3, 4, 5, 6, 7, 8 and 9. We have drawn it so on, but we need only this one. That's why we are using this number. So on the first one, it is 0 upon, you can also write here 0 upon 9. Okay, you can also write here 0 upon 9. So first division is 0 upon 9. Then here we will represent 1 upon 9, 2 upon 3 upon 9, 4 upon 9. This is 5 upon 9, 6 upon 9, 7 upon 9, 8 upon 9 and 9 upon 9 will make 1. Okay, so 7 upon 9 will represent where? 7 upon 9 is this one. If we will write here 10 upon 9, 11 upon 9, 12 upon 9, 13 upon 9, 14 upon 9, if any other number, just like you have to tell that where is 9, 11 upon 9, represent it. Similarly, we will do this one and the answer will be here. Okay, so this is your representation of rational number. Our next topic is rational number between two rational number. This is our new topic. So here, before going to how many rational number between any two rational number, you have to tell me that how many natural number are between 5 and 11. How many natural number? How many natural numbers are between 5 and 11? You can easily tell that it is 6, 7, 8, 9 and 10. These are 1, 2, 3, 4, 5. These are 5 natural numbers between 5 and 11. Same as if we will ask to you that how many integers are between -5 and 2. Okay, how many integers are between, now you have to tell how many integers are between -5 and 2. These are -4, -3, -2, -1, 0 and then 1. You can easily count again. These are 1, 2, 3, 4, 5, 6. Okay, these are the simples for the natural number. Whole number also you can take and integers. Now here we will learn that how many rational number are between any two rational numbers. Suppose I have asked you that how many rational number are between 5 upon 10 and it is 7 upon 10. How many rational number you have to tell? How many rational number? Okay, so here it is, first one is 5 upon 10 and this is your 7 upon 10. So you will see that 6 upon 10. Okay, you can see that it is 6 upon 10. But what about if I will write that this one 5 upon 10 is as 50 upon 100 and it is 70 upon 100. Now you will see that you can see 51, 52 upon 100, 53 upon 100, 55 upon 50, 6 upon 100 and goes on up to 70. Okay, you can see that, you will say that it is 51 upon 100, 52 upon 100 and goes on up to 69 upon 100. Okay, now you will count it again, and if we will, I say that to you that what will be, there will be, now there is, I have written these. Now can you tell me that how many? Again you will say that you will say that these are your 5001 upon your 10,000 and 5002 upon your 10,000 and goes on up to here. Okay, so again you can count. So if we will take like this, can you tell me that how many rational numbers are between any two rational number? These are your not definite. Okay, these are your not definite. That means these are countless numbers between any two rational number. There are countless rational number between any two rational number. You know that there is a countless rational number between any two given number. Okay, earlier we have studied that there is countless rational number between any two given rational number. So we have take here one question, that is your find the tan rational number between minus 2 upon 5 and 1 upon 2. We have to find tan rational number between 2 upon 5 and 1 upon 2. So our solution part is, here the first rational is 2 upon 5 and the second rational is 1 upon 2. The first thing we have to make their denominator same. Here the first rational number, in the first rational number there is denominator is 5 and the second one it is 2. So firstly we have to make the denominator as same. So we will take the LCM of 5 and 2, it will be your tan. So making it as 5 tan, we will multiply 2, and here making as 2, it's multiply by 5. So it become your minus 4 upon tan, and here it is 5 upon tan. Okay, so now it is minus 4 upon tan and it is 5 upon tan. Now you will tell that between minus 4 upon tan and 5 upon tan, how many rational number? You will say minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. Okay, and then comes 5. So it will be on the denominator, what we will write, it is tan, and it will be your these rational number. There it is 1, 2, 3, 4, 5, 6, 7, 8, only 8, but you have to find tan rational number. So now our next step will be, if you have to find any 5 number, the question was find any 5 rational number between minus 4 upon 10 and 5 upon 10, you can easily choose any 5, but here the question is you have to find tan rational number. So now you will do 4 upon 10 and here it is 5 upon 10. You will multiply these two numbers, on the numerator also 10 and on the denominator also 10. Same as here, on the numerator with the help of 10 and on the denominator is also with the help of 10. So it's become now minus 40 upon 100 and here 50 upon 100. Okay, so now between minus 40 upon 100 and 50 upon 100, there is so many number, that is your minus 39 upon 100, minus 38 upon 100, minus 37 upon 100, and it goes on up to 49 upon 100. So here there is so many rational number between minus 40 upon 100 and 50 upon 100. So you can choose any of 10 from these here. So your answer can be vary from your friend answer, because there is, the main thing is countless rational number between any two rational number. So here now you can choose any 10 number between these, so that will be your final answer.